We're going to do the surface area of a shape. We're going to start with a nice simple shape. We're going to start with a rectangular prism. A rectangular means that the outsides are all going to be rectangles of some sort. You technically could have squares, and I would accept that too. So if you had a cube, right, that would be a rectangular prism in my books because a square is a rectangle. It's just a special rectangle. They've given you a picture of what a rectangular prism looks like. So if you look right here, this is a beautiful looking rectangular prism. This guy. Awesome. With 3D shapes, they should be giving you at least, and in this case always, 3 different measurements. They're going to give you a length, a width, and then a height or depth, depending on how you want to word it. If I was to look at this one, how I would like to describe it is I would probably describe this as height. I would describe this as width, and I'd probably describe this as length. But I mean, at the end of the day, you could name them whatever you want, as long as you understand there's 3 things, 3 dimensions. If you prefer saying depth instead of width or length, that's cool too. Awesome. When you're looking at a shape like this, and you want to calculate the surface area. So the surface area is what it would take to paint the outside of it. If you wanted to just cover the outside, you don't care about the inside. You just want to cover the outside edges. Then we need to break it down into all of its faces. Faces means sides. Beside it, over here, they give you like the net picture, which you should have seen before, hopefully last year. It's basically like if you took the shape and unfolded it. Right? Like if you had a cardboard box, a Kleenex box, and you unfolded the whole thing and laid it out. It creates what we call a net. It also allows us to easily see all the different sides that you could have. I'm going to try to label them. It's going to be kind of challenging to label them, but I'm going to try to label them in the picture so you can kind of see what's going on. The bottom of the net, they called C. That would be like this side down here, right? The bottom of the box. Yeah, the floor of it. A and D are the 2 sides right here. This is D, this is A in the background. B and E are like the front and the back of it. Okay, so the B is the front. Actually, we'll say B is the back. And E is the front. So if you're picturing this, that's B back here, and the front of it is E. That's why it's hard to label because it's 3D. And F would be the top. Yeah, man.
F is the top?
Yeah. So I've tried to label it out just so you can kind of picture it. Honestly, I'm not good at doing nets. What I'm way better at is looking at the shape and being like the front, the back, the side, the top, the bottom. Like that's how I would break it up in my mind. However, I understand some people are just better at being able to like unfold shapes and see the net. So we will do a lot of nets in this class so you can kind of see all the edges of it. If you wanted to calculate the surface area, you would have to calculate the area of all those sides, so there's 6 sides, and add them all up. We're going to try that with this guy. So if you're looking, we're going to start with A and D. That's the left and the right side. A and D. If you want to calculate the area of A and D, you're going to do length, which is 3, times width, which would be 5. And that would give you the area of just A. That would be the left side. The right side is going to be identical. So what I would do is I would do length, which was 3, times width, which is 5. And then I would times 2 because there's 2 sides. that would tell me the area of my left side plus the area of my right side. Throw that in your calculator, and you get 30. Now we're going to do the front and the back. You can use the net if you want to do the front and back. I would rather just look at the shape and try to do front and back. So if I wanted to do the front, I would do this, which is 3, times this, which is 8. And that would create the front for me. I would do it twice because there's a front and a back, right? And they're the exact same. So I would do 3 times 8 times 2 because there's a front and a back. If you throw that in your calculator, you should get 48. That would be the area of the front and the area of the back. The last two sides we need to do would be the top and the bottom, which we know would be the same. Looking at this, if I want to do top and bottom, I would view it like this. That's 5. And across here. Across there is 8. That would give me the top. The bottom's the exact same, so I'd multiply by 2. 5 times 8 times 2. Which would give you 80. That then gives you the area of all 6 sides. You just want to add them together to get your total surface area of a shape. In our case, you get 158.
Would that be centimeters squared?
That's a good question. So I don't really care about measurements, like the units. However, if you want to know how to do the units, that's smart. It's going to be the same thing that you have in the question, which in our case is centimeters. And if it's area or surface area, it'll always be that thing squared. So it'd be centimeters squared. And for area, surface area, it'll always be that thing squared. For sure. Okay. We'll do one more together, then I'm going to let you try one on your own. Okay, so we have this wonderful shape here. We're going to try to calculate the surface area of the entire thing. We're going to break it into its sections. I'm going to start with the sides first. The sides would be 6 times 5. That would give me one side of the shape. 6 times 5. Because there's 2 sides to the shape, I'd times it by 2. That gives me 60 for the side of the area of one side. Then I'm going to do front and back. If I want to do the area of the front and back, I do the area of the front, which is 8 and 6. And because the front and the back are the same, I times my answer by 2. That should get you 96. Want to try that? I seem not confident in that. 96? Yeah, all right. That would be the front and back. My last 2 sides would be the top and bottom. Do one of them. So for me, I'm going to do the top because I can always visualize the top nicely. So the top would be here times here. That's 8 times 5. If you wanted to look at the bottom, it might be easier because there's actually measurements on the bottom. But you would still see 8 and 5. So 8 times 5. And because the top and the bottom are the same, we times it by 2. That would give me 80. The surface area of the entire shape would be all of these things added together. So 60 plus 80 plus 96. If you throw that in your calculator, you should get 236 as your total area. And again, it is or this one would be meters squared. You do not need to write the measurements, the units. I'm not stressing about it. Okay, I want you to try the next one completely on your own. Okay, there's nothing there other than just trying to get the total surface area. So I'll give you a couple of minutes to try it, and then I will do it, and you can see if you got it right or wrong. Okay, so I've done the work up there for this one. I've broken it into its sides, its front and back, and its top and its bottom. Your definition of sides and front and back might be different just depending how you look at the shape. For me, I did the sides as this guy right here. And I did the front and back as this guy right here. Okay, that was my definition of it. And then I did top and bottom as this guy. It doesn't matter what you call it. So if you had your sides labeled as my front and back and vice versa, it'll be the same answer. It really doesn't make a difference. My sides would have been 4 times 6 times 2 because there's 2 sides. My front and back would have been 10 times 6 times 2 because there's 2 of them. And then my top would have been 4 times 10. Right? To get my top. And my top and my bottom are the same. So that would have been 4 times 10 times 2. And you should have had all the same numbers as me. Hopefully you got an answer of 248. Cool. We're going to try another one. The only thing that's different is we have a square prism. Honestly, the only difference is that the sides are squares instead of rectangles. Like a square prism is a rectangular prism in my mind. It's just a special rectangular prism. So if you look at the previous answers, yeah, it's just special because the sides are the same. Like if you look, the sides were always different, 4 and 6. This was always a rectangle. A square prism will have a perfect square as its sides, meaning it'll be the same length. But our strategy to solve it is the exact same. Do the sides, do the front and the back, do the top and bottom. And it'll work out just fine. A quicker trick through it is if you recognize you have a square prism, then the front, back, top, and bottom will all probably be the same because the lengths are all the same for all of them. So you could do a little shortcut if you wanted to. I'll show you that shortcut. So if you look at this question right here, this is a square prism. I know it's a square prism because one of the sides makes a square. That right there in blue is a square. We also, for the first time today, are seeing these lines. That means they equal each other. So if you ever see a line through something like that, it means they equal each other. We talked about that last day. Hopefully it's refreshing. Here's how you can do it a little quicker. So if you wanted to do this faster than the last questions, by recognizing that it's a square prism, I'm going to do my top and my bottom right here, the 2 squares, which would be 3 and 3, so 3 times 3. And I'm going to times it by 2, because there's 2 of them. There's the top and the bottom. That gives me 18. I think it's just somebody running.
That was me, bud. That was kids who were upset.
I then can do the 4 outsides, like the long sides, faster, because if it's a square, then they're all the same, right? Like this front will be the same as this side because they're both 3 by 5.6. That means the back is the same, the 2 sides are the same, the front's the same. So instead of timesing by 2, I'm going to do 3 times 5.6 times 4 because there's 4 sides that are the same.
What is it?
3 times 5.6 times 4.
3 times 5.6 times
And that would give you 67.2. So when you have a square prism, you technically could go a little faster and times by 4 instead of doing 2 times by 2. Honestly though, like I don't care if you do it the quick way or the slow way, as long as you're getting it right. You then add up your stuff. So it'd be 18 plus 67.2 You get a total answer of 85.2. Awesome. On the next page, we have another example of that. I want you to try it on your own. I'll give you a couple of minutes to try writing it out. That is a square prism. The square is just bigger than the rectangle, so it looks a little funny, but you could use our trick. Yep. We're going to try to calculate the surface area of this thing. You don't just go length times width times height. That's not surface area. The surface area is all the sides broken apart and then adding them all up. I'm going to start with the sides of this shape. The first thing people struggled with was this double line thing. If you get two lines like this, of course, you're going to break right now.